Hello folks, welcome to our first episode of the Distributed SQL for Java Application Developers series. And in this episode, we'll take a look at the dynamic update annotation of the Spring Boot and Hibernate ecosystem, and you will learn why and when should you use this annotation with YugabyteDB and your distributed SQL applications. Let's go. Alright folks, let's take a look at our sample Spring Boot application. The application comes with typical components such as repositories, services, and entity classes. We will create just one table, the pizza order. The table comes with 3 columns: ID, order status, and order time. So the database is YugabyteDB. We are connecting to YugabyteDB through the properties class, and it's running on my local laptop. Our focus for today is the dynamic update annotation. That's why let's jump to the pizza order class. That's an entity class, and which is mapped to our table. It has the same fields such as ID, order status, and order time. But it's also annotated with the dynamic update annotation. And with that annotation, Hibernate will generate a SQL query, an update query that updates only those fields that were changed at the application level. So why we need it and how it works, let's check it out. For the first experiment, let's turn this annotation off and jump to the dynamic update annotation test. So what this test does, after starting, it will remove all the existing records from the database, and then we will add the only one order with ID 1 and the status ordered. Finally, we will do the sanity check. We will make sure that this order exists. And lastly, we will try to change the order status. We will read this order, we will change the status to the baking, and we will save it back to the database. Let's run it and see what's happening. Interestingly, as you see, here is we requested at the application level to update only the status, but Hibernate send the following query to the database, and in that query we are updating both the status and the order time, but the order time's value remained the same. And this is how the dynamic update annotation can be useful. It can instruct Hibernate to send only those fields for the update if the fields were changed at the application level. Let's go back to the pizza order class and enable this annotation. After that, we are jumping back to our test and we are restarting this test. Okay, let's open the console. And now you see that Hibernate followed our advice. It listened to the dynamic update annotation, and when we update the status column, only the status column gets updated. And now the question is, why is it useful, and why is it useful specifically in YugabyteDB? YugabyteDB uses the column level locking for records. Imagine that you have two transactions. One transaction attempts to update the status column of your order, and another transaction is trying to update the order time. In YugabyteDB, those transactions can execute concurrently if they do not intervene with each other, because the logs are put on the column level and not on the entire row like it happens in Postgres, MySQL, or Oracle. This is why the dynamic update annotation in YugabyteDB helps you to minimize the contention and improve your scalability and performance for your transactions that run in parallel. So let's run another test. The final test will be executing 2 transactions in parallel. The first transaction will be updating the order column, and the second one will be changing the order time column. So this is the method that will be executed by the first transaction. We will change the status, flush it to the database, but the change will not be committed immediately. Instead, the transaction will reduce the Java level ledge counter, and then this transaction will sleep for 10 seconds. Only after that, the transaction will awake, this method will finish its execution, and the commit statement will be executed by the Hibernate framework. So the second transaction also in parallel will attempt to update the order time column, but before it will not start with the changes until that ledge is released by the first transaction. But once this happens, it will change the order time, it will save the changes to the repository, and then when it will be exiting this method, Hibernate will issue their commit statement. To run this test in parallel in Java, let's use this final method. The method makes sure that you can update columns concurrently in YugabyteDB. So what happens here, we have the executor service with 2 threads, and the first thread will be updating their order in the transactional context. I hope you're familiar with these annotations. And the second thread will be updating the order time, also in the transactional context. Then we will wait when these both threads have finished and when those transactions are executed. So now let's run this test with the dynamic date annotation disabled, and let's see what happens with this test. Starting the test, opening the debug console. So what we see here, that the first transaction executes the update of both columns, but right now it's sleeping. At the same time, the second transaction, you're able to proceed, but the first transaction commit failed. As long as both transactions, we're trying to update order time and status, order time and status. And this is why during the commit of the first transaction, YugabyteDB detected a potential conflict and failed the first transaction. In reality, it also might be that their second transaction will fail or the first fail. It all depends on the execution flow. So right now, let's remove these unnecessary columns updates. So we want every transaction to update only the columns that were changed by it at the application level. For that, as you remember, we need to revert this change. We need to enable the dynamic update annotation, going back to the test. And right now, let's execute the test. So this time the second transaction also committed successfully because it was updating only the order time, no more updates for the order status. And the first transaction was trying to update the status column. Okay. Then when the first transaction awoke, it updated successfully, and YugabyteDB did not detect any potential conflicts because each transaction was updating just one specific column belonging to the same record, but the columns were different, and YugabyteDB put logs on the specific columns and not on the entire row. So this is how YugabyteDB benefits from the dynamic update annotation of Hibernate, and my advice to you folks, make use of this annotation to make your distributed SQL applications more scalable and more performant. So if you like this video and if you like what we do, support us by subscribing to our channel and ring the bell and let us know if you have any other questions, and stay tuned for new exciting videos related to distributed SQL and Java. Bye bye now.